Okay, so this is the last part of today's lecture. In this lecture, we will discuss the array of. In this part, we will discuss the array of structures, and the array is class member data, and then the array of objects. So, starting with the first one, which is the array of structures. So, if you recall, you might have studied this in your first course before this one. That we have we can have structure just like we say, for example, integer a, integer b. So the variable is of type integer. So similarly, we can have structure which helps us in grouping of data elements. So for example, if we say a structure, we do this with the help of this keyword struct to define this as a structure. The name of the structure is part, P-A-R-T, and it contains these three elements. So we group this data together with the help of this structure keyword. So now what do we have? We have in memory, we have a space allocated for the three variables, integer model number, integer part number, and then the last one is the float cost. So three variables, these three places would be allocated to any instance of the structure of the type with the name part. So this has been a prototype is defined over here. Now in the main function, if we say, for example, just like we say integer a, just since we have a structure with the name part, so we can similarly say part a. So what this will do, this will generate a structure with the name a, and this is of type part. What is part? Part is defined over here. It has got three data members grouped together. So a would have three members just like this one, and the first allocated memory would be of type integer with the name model number, second would be part number, and third would be cost. So if you want to load some number to the first location, you have to write what, since the name is a, and what do you want to do? You want to save some number in the model number, so you just write a and then model number, and say equals to 5. So 5 would be saved in the model number of the a structure. Similarly, you want to say some a dot part number, so you say a dot part number, and then this equals to say 10. So the part number of this is equal to 10, and similarly for the last one. If you want to, so this is equal to just what, one element generated of type structure. Now if you want to have an array of such elements, for example, just like we said, this is a, part a is a structure with these three elements. If you want to say I want to have multiple such elements, multiple such structures, so you can do this with the help of this array. You can say a part and then you say size. For example, you say there are two elements, so then a part 0 would be a part 0 would be the first element, and what would be inside there? We would have what, three locations. First is the model number, second is the part number, and third is the cost. The first two are of integer type, third is of float type. Then a part 1 would be another structure. So you can see from it is an array of structures, and the second one is indexed as 1, and again it would have what, a model number, a cost, a part number, and a cost variable. So if you want to access the first element, you would have to say what, a part 0 dot model number, just like this one. So if you want to write something from the user, you just write c in a part 0 dot model number. Whatever the user enter would be saved in this location. You say a part 1, so this would mean this element, and inside this element we want to refer to say the part number. So part number, then a part dot part number, a part 1 dot part number would simply refer to this point. If you say this equals to some number, it would be saved over this location. So you can see from here, this is one structure, this is another structure, and this is an array of structures. And how you define it, just like we did earlier, say integer a 10, so it would be an array of 10 elements, and name would be a of type integer. Here we say what this is an array of type part, so it's a structure. The name is a part and the size is 2, so it would be a structure array of size 2. So there would be 2 structures, and you can access the elements just like this one. So in this example, what do we have? The same thing. We have a structure prototype defined above. So a structure is specified with the name part. There are 3 variables. In this example, then an array is declared, and the array size is defined over here. It's a global variable, and the size equals to 4. So it would be a 4 size array of structure with the name a part, and so there would be 1, 2, 3 and 4 structures. All of these have got what the name is a part. This would be a part 0, the second is a part 1, then this is 2, and this is a part 3. If you want to save some number, or for example you say get values of all the members from the user, you want to say what are the values of the first member, ask the user to enter the values of the second member, ask the user to enter for the values of the third member, and so on. So you have got how many structures? 4. So you have to run a loop 4 times. You can do this by declaring, so you say integer n equals to 0, n less than size n plus plus. So n equals to 0, which is less than 4, so the loop would execute, and when we come back over here, n would become equal to 1. 1 is still less than 4, so for 0 the loop would execute. When n equals to 1 the loop would execute. When n equals to 2 the loop would execute. When n equals to 3 the loop would execute. When it becomes equal to 4 here, then the loop would not execute. So this loop would execute 4 times, and each time, say for example for n equals to 0, then what would happen inside this this loop? First a new line, the cursor would move to new line, then it would ask the user to enter model number, and then it would wait for the user to enter a number. When the user enter number, at this time n equals to 0, so a part 0 dot model number, the number would be saved in the a part 0 dot model number, it would be saved here. Then it would ask the user to enter part number. So since n equals to 0, so a part 0 dot part number, this would be the user would, when the user entered the number, it would be saved in the second location, and then it would ask the user to enter cost. It would print this thing, and then it would wait for the user to enter a number. Since at this time n equals to 0, so a part 0 dot cost would mean this location, and when the user enter a number, so it would be saved in the this location. So for the first structure, the user would enter these 3 numbers. Then when the loop n would become equal to 1, and since n is less than 1, so the loop would execute again. So now n equals to 1, so again the loop would execute. Again there would be a new line generated. Then it would ask the user to enter model number, but since this time the n equals to 1, so a part, here we have what, here there is n written over here. So a part, since n is 1, so a part 1 dot model number, which refers to this location. So in the user enter number, so it would be saved in this location. Then for the next one, a part 1 dot model number would be saved here, and then it would save the last number in the this location. And similarly for the remaining 2 structures, it would ask the user to enter numbers, and they would be saved in these locations. After this being done, then there would be another loop which simply print out these values of the data members of all the structures. So you can see from here model, part and cost. So it would first print the model, part and cost of the first element. N equals to 0, so a part 0 dot model number, a part 0 dot part number, a part 0 dot cost. So these would be printed for the first element. Then n equals to 1, so it would print for the 1. Then when n becomes equal to 2, it would print for the third structure. then becomes equal to 3, so it would print for the fourth structure, and that would be it. So the print out would be simply equal to what? It would first ask the user to enter numbers, 4 numbers entered by the user, and then it would print the model number, part number, and cost of each element. Then in the next loop, model, part, and cost of the second structure, third, and similarly fourth, and this would be printed at the end. So this is how we can make an array of structures. This example pretty sums up everything. And how they would occupy space in memory. So they would just simply, the first structure would have the first space, then the next element of the array would be simply adjacent to the first one, and so on. Then a part 0 dot, say this is the part number, so a part 0 dot part number would be this element, a part 0 dot model number, the first one, then the second the part number, and then the cost would be saved here. Then similarly a part 1 dot model number would be here, a part 1 dot part number, and dot cost. So you can see from the diagram. And similarly for the a part 2 dot model number would simply mean this location, a part 2 dot part number would mean this location, and a part 2 dot cost would mean this location. So if you want to save some number at this location, you just call this by this this variable. If you want to save some number in this, so you can call this by this variable, and you can say this, consider this to be the name of this variable, this place, and you can write some number, you can read some number by using this name. So this is an array of structures, and how do we write and read the elements, how we can make it. So this is pretty well explained in this example. Next we have arrays as class member data. So in this topic, what is being discussed is that, for example, when we define a prototype of a class, we say there are data items, say private, integer a, integer b, and we say public, we have got member functions. So here this topic says that for a particular data item, instead of just saying integer a, we can write an array of the elements. For example, you can, instead of, you can write integer a, integer b, or you can say instead of making the two variables like this one, you can instead say integer a of size 2. So integer a and size 2. So this would make an array of two integers. The first one would be with the name a0, second one would be indexed a1. So we have got made two integers. Here also we have two integers with the name a and b. Here we have made an array of integers. So these can be the data item, and this can also be the data item of a class. So that's pretty much everything explained in this topic. So the point is that we can make this data item as an array. Here the example that is discussed is about the stakes. What is a stake? So for example, in normal daily life, if you receive a file, you place it here. If you receive another file, you place it on top of the first file. If you receive a third file, you place it on top of the third of the two. If you have another file, so you place it, if you want to place it together, you place it on top of the three. If you want to access it, so first you access this one, then you access this one, then you access this one, and the last item that could be accessible is this one. So this kind of a structure is called as a stake, and you can see from here the item that enters last. For example, this is the item that is entered last, so this would be the first to go out of the stake. So this is also called as last input and first output structure, and this is a very important data structure that can be implemented in the both the software and hardware, and we would discuss here a program that creates a simple stake class. So we would make an object, we would define a class that would help us in that would be of type stake. We would make a stake with the help of the object-oriented programming, a class of the stake, and then we can make different objects based on the prototype. So the prototypes would simply be stakes: stake 1, stake 2, stake 3. So in these different stakes, you can enter numbers, say the first number, second number, third number, fourth number. You can enter in these objects. So you made one pile, one stake of the data items. You can access the top element, then the next element, and then the next element. You can make another stake, an object of type stake, so that would be a stake, the second stake. You can push numbers, and you can pop numbers from this one. So you can simply, if you want to push numbers, so say this is the first location, number would be saved here, then the next one saved here, the next one saved here, and so on. If you want to pop, say this is the last location, so this would give you the last number entered from this object. The second last number stored would be here. You can access this next, and then this one and this one. Say you want to have a third stake, a third pile, you can store numbers in this pile as well. So the first number stored would be at this location, then going on to the top, and say you want to access the elements of this stake, of this pile. So this would be the first element accessible. Then after you access the first one, you can then access this next one, and so on. So in this example, a prototype of stake is developed, and then the different objects are generated. They are the different piles, you can say. They are the different stakes, and then you can store data in these different stakes. So in this example, this is shown how we can do this thing. So with the object-oriented programming, the classes and the objects, you can implement this very important data structure. So let's see what is shown over here. So a class is generated with the name stake. So this is the name of the class. The blueprint name is what? Stake. And what is inside stake? You can just write 10 over here. So you say an integer with the name st, an integer array of the name st with the elements 10 is generated. So in this class, what do we have? We have a data item, and it has got 10 elements. Sorry, we have an array with the with 10 elements, and the name of this is what? st. So the first data item st is an array with 10 elements. So the first one would be at st.0, sorry, st0, then st1, and all the way up to st9. Then what happens next? We have another variable of type top. So this is another variable, a data item in this class with the name top. So the name of this one is top, and you can see from here the top is assigned the value 0 in this constructor. So top, this would initially this would be equal to 0. This is one member function. This is another member function. What is this member function doing? The name of this member function is push. So normally when we want to insert some data into the stake, so we say we are performing the push operation. So that's why the name of this function is kept as push. So there is one data member which the name of push. And what is this push doing? Push is asking for a variable. You can see from here it takes a variable. Once it takes the variable, then that integer variable, you can see from here it is assigned toward to the top of the stake. So you can see from here, for example, the top is equal to 0 now. So what happens in this function, in this member function, that the number that is taken, it would be saved where? It would be saved in the st, which is the stake. At which location? At the plus plus top. So when this line executes, first the top would become equal to 1. So top would refer to this location, and then the number variable, it would be saved at that st1. So the number which the member function takes, it would be saved over here. Then for example, if you call this function again, so it would again take a number, and that number would be saved where? First the top would become equal to 2, because plus plus top means increment top by 1, so top would become equal to 2. Then st2 is the location where the variable would be saved. So if you push another number, it would be saved over here. If you want to push another number, so you call this member function. So this member function would take a number from you, and the number would be saved where? The number would be saved at the top of the stack. And where is the top of the stack? St is the stack name, and at this moment with the plus plus top it would become equal to 3, because initially top is equal to 2, so now plus plus top would make it 3, so it would refer to this location and the number would be saved here. If you want to push another number, so plus plus top would make it 4, and then the number taken would be saved at the st4, so the number would be saved here, and so on. So this is how you can save number in this stack. It would grow in this direction. If you want to access a number, so as we said that the number should be accessible from the top of the stack. So if this is the top, so what happens is that we want to access number, so we write another member function for this one, which is called as the pop member function. Since we just say what is the number at the top of the stack, so we should not provide any number, so that's why there is no argument. And what do we expect from this function? We want the function to give, so there is another member function with the pop, and we want this member function to provide us the value of the top of the stack. So at this moment the top, for example, if you the last number entered is at the 4th location, A4 st4, so the top is equal to 4, so it would provide you the value of the top element st4. It would be returned. If you call this function, it would simply return you with the value of the top of the stack, and then it would decrement this top, so top would become equals to 3. So top would become equals to 3, so now top would refer to the 3rd location. If you call this member function again, you say I need another element from the stack, so what it would do, it would return you, if you call this function again, this would return you st top minus minus. At this moment if top is 3, so it would return st3, so it would return you the value at the top of the stack, and then it would decrement this top by 1, so top would become equal to 2. If you want to access another element, again call this pop function. This pop function would provide you with the value of st2, and then it would decrement the top by 1, so top would then refer to 1, and so on. So this is how you can implement a stack in the programming. So this is the class for the stack, and then in the main function, if we say a prototype, we made a prototype over here. So we say we have got a stack, and then we have got a top variable which refers to the top of the stack. Then we have got two member functions, and with the help of the first member function we can push a number at the top of the stack, and with the second member function we can retrieve the element at the top of the stack, and the first member function would increment the top by 1 before it push any number. The second member function would decrement the top by 1 after it provides you the number. So this is the prototype. In this example, an object of with the name s1 of type this class is generated. So once we generate this thing, then we would have what? We would have an object s1 generated, and it would have an integer array over here, and a variable over here, and two member functions over here. If we say s1 dot push, so actually we are calling what? We are calling the push member function of this object s1, and we say s1 dot push 11, so we provided the number 11 to it. You can see from here variable would get the number 11, and then that 11 is saved at the top of the stack. So since this is what member function of s1, so this would save the number at the top of the stack. The second number is 22 provided, and we say push this number also into the stack, so it would call this member function of the stack and would push the number at this location, and so on. If we say push 33, push 44, push 55, push 66, so it would simply save these numbers in the stack at these locations. And if we say pop the number, so it would first provide you the last number, then the next second last, and the third last, and the fourth last. So it would provide you the number, and it will also change the value of the stop variable with every push. So this is a very good example which says that we can actually have an array of data items in a class. Okay, so these are the details that I just covered above, and you can see from here is that these are the data items of the stack, and if it grows downwards, so the first number would be saved here, the second would be saved here, the third would be saved here, and fourth would be saved here. If you save here, this is the last saved number, we say this is the top of the stack. If you access this number, then the top of the stack would actually refer to this number, this location. If you access this one, then the top of the stack would be referring to this location. If you access this number and you say again I want to push another number, so it would simply overwrite 55, and then the top of the stack would be this location, and the number would be written over here, and so on. The stack can grow again as well. Okay. Then the last topic in this chapter is about the array of objects. So array of objects simply means that just like we said that we can have data items, an array of data items. We said we can have an array of data items, and we can make an object. So in this case we say that we can also make an array of objects. So we say that S14, for example, if we write here stack S14, so what will this do? This will make 4 objects. This would be S10, the next one would be S11. Okay, the index would be S11, then S12 and S13. So it would make 4 objects. Okay, and this would be called as an array of objects. You can see from here this is an array. Okay, and it has got 4 elements. The first element would be S10, S11, S12, and then S13. So we got 4 objects. If we want to write some number into the stack of the S1 object, so you just say what? S10. You are referring to S10 element. Inside this element you want to call the member function push, so you just say push, and since you have to provide a number, so just like for example you say write 11, so this number 11, the member function of S1.0, it would be called, it would be given the number 11. What will this do? This will save the number at the top of the stack. This will save this 11 at the top of the stack. Say again you want to write some number, so you in the same stack, so you say S1.0 and then say push and say 20. So the second number 20 would be taken by the member function of S1.0, and it would be pushed at the top of the stack, and if you write many numbers, it would be simply written over the different in the stack. Similarly, if you want to pop, you can just say S1.0.pop, so it would give you the last element entered. Then if you say S10.pop, so it would give you the next element, the second last element, and so on. Similarly, if you want to push some numbers into this stack, so you can say S11, so it would be then be the name of this is S11, it is indexed as 1. And if you say push 11, so this 11 would be pushed at the top of the stack of this object. S11 dot push 20 would simply push the 20 in the next higher location, and so on. If you want to pop, you say S11 dot pop, so it would call the member function of the second object, and then it would do the task which is written in the code of that member function. And similarly, so in this last one topic, it is said that we can have not just one object, but we can have an array of objects. Okay, so we can have an array of objects. So in this example, if you recall, this distance class we generated this many times. This is again written over here. What is this class having? It says that we can have two variables, feet and inches, and then the first member function asks for the distance from the user, and second one would show the distance of that particular object. If we say distance 100, so the blueprint says what? The blueprint says that we have two data items, inches and feet are the data items of this one, and then we have got two member functions, and the first member function would ask the user and save the numbers in the feet and inches of the data items, and the second member function would print simply the value of the data items. This is the prototype. This is the distance class. If we make an object distance, so it would be simply it would generate two data items and member functions, and the name of this would be distance. If we say a distance 100, so it would make 100 objects. The name of the first object would be distance 0. Similarly, another object would be generated, and the name of the second object would be distance 1, and the name of the third object would be distance 2, and so on. Each of this object would have two data items because this is made on the basis of this blueprint. So each of them would have two data items, feet and inches, and then we have got two member functions. The first member function would ask the user to enter two numbers. The first number would be saved in feet, the second number would be saved in inches, and then the second member function simply print the value of the feet and inches. It would provide these two numbers to the user. So for each of these 100 objects, there would be two data items, two member functions. It would be of type distance, and they would be indexed from 0 to 100. So if you say distance 0 dot get distance, so the member function of this distance 0 would be called, and it would ask the user to enter two numbers, and they would be saved in these two locations. If you say distance 1 dot get distance, so this member function would be called. It would ask the user to enter two numbers, and they would be saved in these two variables, and so on. The last item of object of this array would be what? It would be, as you guessed correctly, it would be distance 99. So this would be the last object. Okay. So in this example, again, you can see from here distance n, so which means that you are referring to a distance object, distance 0, 1, 2, 3, and it will ask the user to enter number. If you want to continue, so there is a simple code written over here, and it would simply ask the user to enter different numbers as long as the user wants, and then stop at the point where the user says no. So that's all for this. You can just go through this program. That's all for this today's lecture. If you have any question, you can ask me during the interactive session, and please keep in mind we have a quiz scheduled tomorrow during the lecture time, during the interactive session. So please, every one of you should make sure that you are present. The quiz would be in the previous chapter, that is the objects and classes. So wish you best of luck. If you have any question, you can ask me.